Hey there, it's Miss B here, and we are looking at Illustrative Math, Unit 1, Lesson 2, the cumulative practice problems. So, let's hop in with question 1 right here. This diagram was created by starting with points A and B and using only straight edge and compass to construct the rest. All of the steps of the construction are visible. Describe precisely the straight edge and compass moves required to construct the line CD in this diagram. So to help me see it a little bit better, I'm going to highlight line CD here. This is our end goal. How do we create this line? We want the moves required to construct line CD. Okay. So first off, we are starting only with points A and B. So I'm going to try to write a little small here. That way I have enough space, but we'll start with our first step of, if we were using a physical compass, we would use a compass to construct a circle. Although most of our constructions we've been doing with Desmos, you can use the circle tool. So even though I'm going to describe it as using a compass, you can also use the circle tool to achieve the same effect. So we are going to construct a circle centered at A with radius AB. We can say using a compass. So what that's gonna do for us is create a circle. So I like to highlight things. I'm gonna highlight this circle here. That is what we have just made. Now, we're gonna do the same thing, but starting at point B. So our next step would to be construct a circle centered at B. And then we can say with radius AB using a compass. Okay, and that, oh, I did have a little bit more space. I thought I was getting close to the edge there. That will create our other piece here. So the yellow highlighted circle. So now I have almost all of these visible points, except I'm missing a couple little things. Um, Points C and D don't just appear randomly. We actually have to identify them and label them. So we're going to say um, label the intersection of circle A and circle B. Or we could say label the intersections of circle A and circle B. Point C. We're going to label them point C or just C. And point D. Okay, so now, according to our steps, point C and point D exist. So now these exist and they're labeled. And since this is compass, and straight edge. If we were using this physically on a piece of paper, we would use a straight edge to construct the line between C and D, or the line passing through it. On Desmos, we can just use our line tool, but we're going to describe this using a straight edge. Either way, we're going to construct the line that passes through point C and point D. So we can say use a straight edge, basically the same thing as a ruler. Use a straight edge, and I'm actually going to say or the line tool to construct a line passing through points C and D. And that is it. That is the full diagram. But we do have to be very intentional and specific with the words that we use. So it does take quite a few steps, or it's a little bit wordy, but we want to be specific, and those are all of our moves required. And it does say that we need to describe precisely. So I think we were successful with that. We described them precisely. Let's take a look at the next problem. So for number 2, oh yay, we don't actually have to list out a whole bunch of steps, but we are going to try to figure out some things about it. So A is the center of one circle, and B is the center of the other. So A right here in green, that's the center of one circle, and B is the center of the other, so I'm going to highlight B yellow. I might have to come up with different highlighter colors if these are a little too difficult to see on video, but for now, green and blue and yellow work pretty well. So A and B. Now our job is to identify all segments that have the same length as AB and then explain how we know. So we want all segments, and we want them to be the same length as segment AB. So AB goes from A to B. Now, we want to identify all of the other possible segments that are that same length. Now, from what it looks like to me, A is the center of one circle and B is the center of the other. So that would mean that AB is a radius. It's a radius of circle A and it's a radius of circle B because of the way that they intersect. So I can identify every other radius of circle A, and I'm going to highlight those here in blue. So anything that goes from A to the outer part of the circle here, so that's AC and also AD, and I also have AE coming out this other direction. Those are all those same lengths. Now the question is, does B have any of those? And B does. I am going to, my colors are getting a little funky here. You know what? Let's make the one centered at B yellow. So the radius may be centered at B, that extends out to the end here would be BC and BD. And of course, AB itself, or BA, would also be a radius. So now that we actually have those pieces identified, let's see which of those are our options, since this is multiple choice. So it says segment AC. Segment AC, I would agree, that is one of my solutions. It also says segment AE. I would agree, that's one of my solutions. Segment BC, I would agree. That one is also one of my solutions. It is a radius of that same circle. Oops, that's an eraser. Pen. Now segment CD. CD is one we actually do not have highlighted here because it goes a pretty longer distance. Definitely looks longer than CB, but it's just not a radius of this circle, so no matter what it looks like, we know we can't say that it's congruent because it's not a radius. So it's not going to be segment CD. And then our last one is DE, and that actually is this part over here on the side. Not one of the options I had highlighted, so not going to be one of my solutions. Now, why did we choose A, B, and C for our options here? We can say these segments are radii, which is the plural of radius, of um, two identical circles. So the word we use for identical is congruent, so I'm going to say these segments are radii of congruent circles. So they must all have the same length. And that's all they want us to identify for this question. Just which ones have to have the same length as AB. And because we knew that AB was a radius of both of these circles, that meant that any radius of circle A and any radius of circle B would have to be congruent, or would have to be identical, or have the same length as that center piece. So let's move on to the next question. I'm going to have to flip my page here. We have another diagram. So this diagram was constructed with a straight edge and compass tools. So if we were using Desmos, we wouldn't necessarily call it our straight edge and compass, but either way, one constructed on paper or one constructed with Desmos would still give us mathematically correct things. So let's look at this one. It was constructed with straight edge and compass tools. A is the center of one circle, and C is the center of the other. Select all line segments that must have the same length as segment AB, and explain how you know. So this is very, very similar to our previous question, because I have A being the center of one circle right here, and C being the center of the other. Now it's asking me for anything that is the same length as AB. So I'm actually going to highlight AB, not AC. AB is right here. Now, because these two circles don't pass through each other's centers, we know that the two circles are not necessarily congruent to each other. So while B is an intersection point of these two circles, it doesn't mean that any radius containing B is going to be equal. We actually don't even need to look at circle C at all, because only a certain number of these are going to be true. But let's look at our first option. Our first option is AB. So is a segment the same length as itself? Yes. A segment will always be the same length as itself, so AB is going to be congruent to AB. AC. I would agree with AC because if we look over here to the right on our diagram, that is a radius of circle A. It goes from the center at A, and C is on the edge, so it does extend to the edge of the circle. So I would agree with that one because AB is a radius, so any other radius of circle A does have to be the same length. Now BC, this is where it comes into play. So BC, this is a radius that contains B, but it does not have to be the same length as this one. We only want ones that have to be. So in this case, not BC. That also does not mean anything about BD. We do not know. This could be the same length, but it does not have to be. And this one said must have the same length. So there is no way for us to prove this right now, which means we are going to say, nope, that is not the same length. And CD would be the same length as CB, and CD is not going to be the same. So explain how we know. How do I know that AB and AC are going to be the same length? We can say AB and AC are radii of the same circle. Okay. And it looks like we only have one question left after this. So let's look at our very last question. Again, using compasses to make circles. Claire used a compass to make a circle with a radius the same length as segment AB. So um, it is the same length as segment AB, and AB is right here. She labeled the center C, so which statement must be true? Well, she said the radius is the same length, and a radius goes from the center of the circle to the edge of that circle. So I know that FC is going to be the same length. And all of these statements here on the left are saying that pieces are equal. So is AB equal to CD? No, because CD would not be the same length as AB. It's not a radius. And she specifically constructed this where the radius is the same as AB. So not the same. What about A, B, and CE? CE actually extends all the way outside the circle, so it goes past. It is actually going to be larger. So it can't be this one either. AB equal to CF. Those are the two pieces I have circled or highlighted, I guess is the more accurate term here. Now AB equal to EF. EF is the little chunk outside of our circle over here on the right. AB is not necessarily equal to EF. So we're going to cross this one out. How do I know? CF is a radius of circle C, which has a radius the same length as AB. So that's how it was constructed. And so since we know that it's a radius, it has to be the same length. And I believe that's it. Yep, my next assignment here is assignment 3. So that is it for us on Unit 1, Lesson 2, Cumulative Practice Problems.